we're going to go through the notes. I'll get you started on your homework, and you can finish your homework. And as I'm checking one homework assignment, if you remember, I said that yesterday. Okay, so what we're doing today is something called Pascal's triangle, all right? Ignore all of that. Take a look at Pascal's triangle down here. Pascal created this triangle to assist us in expanding binomials, which I'll explain to you in a second. And so we're going to learn how to recreate this because we do need to know. It's super, super easy. You might start already noticing some patterns in it. But what it does for us is it helps us to expand a binomial. So binomial is two terms with a plus or a minus in between. So like if I said to you to expand that, what I would mean is what you guys probably call it is FOILing, right? Or the distributive property. You could write that twice and you do 2x times 2x and all that stuff, and then you combine like terms, right? What if it was a 3 here and we had to do 3 of them? Well, yuck. You have a mean teacher to make you do that. It's a lot of work, but it's doable. You'd have to FOIL 2 of them together and then distribute the 2x and the 1 to all of it. It'd come out with 9 different terms. You'd have to combine. It's a lot of work. What if it had a 5 here or a 7 here? Obviously, that's unreasonable. It's doable, but we wouldn't even finish one of those in the whole class period. It would take so long, okay? So Pascal's triangle assists us in expanding something with expanding a binomial too, with a really big exponent, okay? And so before I even show you the example of how it works, I want to show you the patterns in it and help you to learn how to create it. So we're not using any of these notes up here. I simplify this assignment. They make it so complicated. It's really simple. Let's just use some space here or wherever you want to make a triangle, because I want you guys to practice it. So getting it started is always the hardest part. You just have to remember to make your 3 ones, okay? So there's a 1, those ones. This is what I just created. And the way we continue after that is you add the 2 numbers together. So this is 1 plus 1, which I'm going to put the answer right in between them. And there's nothing else to add, so I just put 1s on the outside. Then just go left to right adding. 1 plus 2, I'm going to put it right in the middle, is 3. 2 plus 1 is 3. 1's on the outside. Everyone should be writing. Adding left to right, 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Nothing left to add. 1's on the outside. And this goes on forever. We're going to go down to 7. And my last row, okay, but it does keep going, all right? So getting it started, 1, 1, 1, and then just add, when there's nothing left to add, 1s. Add 1s, adds 1s, add 1s. Okay, so does anybody have a question about how I came up with those numbers or anything? Because I want you guys to understand. Okay, so we're going to use this triangle on the next page to do some examples, and then we'll recreate it one more time together in the homework. So you practice recreating it, and you'll have it right there on the page where you do your homework problems, okay? So just hold on to that. Before we go to those examples, though, I'm going to use the nicer version, not mine, of triangle to explain a couple different components of it to you. These are rows, right? Row 0, though, is what we start with. That's weird to start counting with 0, but it will make sense in a minute. We count row 0, row 1, row 2, row 3, row 4. So what's nice, though, is if I said to you which row is row 5, instead of having to count 0, 1, 2, 3, 4, 5, you can find the row that has the 5 in it. That's considered row 5. This is row, without looking at that, this is row 3, this is row 4, this is row 2, okay? So it's 0, 1, 2, and so on, all right? The other thing that's going to help us in our second of 2 types of problems we do is counting left to right. If I wanted to know what each of these terms are, this is the 0 term, 0, 1, 2, 3, 4, 5. You always start counting with 0 in this triangle, from top to bottom and left to right. It's 0, 1, 2, 3, and 0, 1, 2, 3, okay? and I'll explain that again when we get to it. So look at the next page and go to example 11. Ignore everything else on the page. I swear sometimes in math they make things so much more complicated than it has to be. I'm going to explain example 11 to you, and you're going to totally get it, okay? You will. So what you do first, every time you get one of these, is you look at what the power is, okay? So they want us to do x minus 2 times x minus 2 times x minus 2, and we're going to do that using Pascal's triangle. Starting with the 3, you get your row 3 numbers. So look at your triangle, find row 3, easy to find because it's got the 3 in it, and just put them somewhere so you can reference them. We need those 4 numbers, okay? Then this little box I'm doing right here is just me organizing some information. It's not part of something I would check for you, but let's just do it together in the beginning. There's an x in here, and I'm going to put it in parentheses. You'll see why in a minute. And there's a negative 2 in here. This is everything we're working with is in this box. So row 3's numbers. The first term is x, the second term is negative 2. Remember, a sign in front of a number stays with that number, okay? So this is everything we need to do that. So here's what we do. And you want to write kind of neatly. If you write really big, just maybe try to write a little smaller, especially if the exponents get bigger, because we're going to write a lot going left to right. I'm saying that more for myself because I write so big all the time. So here we go. What we do is we start with our first coefficient. Coefficient is a number in front of a letter, okay? So our first coefficient is 1. So I'm going to write 1. And I'm going to take my first letter or number, whatever is right here, which is that x, in parentheses, and I'm going to put it to the power of whatever is on the outside, the 3. Whatever they gave us to start with, that's what we start with here. And then we do the negative 2, and we do it to the 0 power. Now, I'm not going to explain that to you. I'm going to do the next 2 of them, and then I'm going to come back and see if you guys can pick up on the pattern that's happening here. Now, I'm going to go on to the next coefficient. So I'm just going to put a plus sign here. Always just put a plus. So I'm going to have 3 in parentheses x to the second in parentheses negative 2 to the first. Stay with me. It's okay if you don't know what I'm doing. You will in a minute. Next one was a 3. Again, second 3. In parentheses, x to the first. Does anybody know what the negative 2 is going to have on it? Nope. A 2. Let's see what I did. On my x's, I counted down. 3, 2, 1. Look what I did on the negative 2's. 0, 1, 2. You count down on your first term, up on your second. Notice something else. I'm not done. I still have to do the 1. Notice something else. All of my exponents, the sum, if you add them together, is 3. 3 plus 0, 3. 2 plus 1, 3. 1 plus 2, 3. Okay? Last one would be plus this 1. X to the what? 0. Look, 3, 2, 1, 0. And on the negative 2, 0, 1, 2, 3. 0 plus 3 is 3. Notice I never went higher than 3. I didn't go up to 4, right? You never do. And it's just a pattern. Once you get it started, it's the same thing over and over again. And we're going to do another one in a second, so just if you got a little lost in there, I promise you'll be fine, okay? Now we have to simplify that, all right? So here's the thing. There's so many, when we get to our final answer, I'm going to show you a bunch of patterns that will help you see if you made a mistake in your arithmetic that we're about to do. But let's cover a couple things. Anything, listen, anything to the 0 power is 1. So if it has a 0 power on it, it's just a 1. Whether you're a number or a letter, it just becomes 1. Okay? Let's talk about this. If you have something in parentheses with a power on the outside, that power applies to everything in the parentheses, okay? So that's 2 squared, which is 4, x squared, which is x squared, right? One more thing let's talk about. If you have a negative number in parentheses, you have to be careful with your signs. If you have an odd exponent, you're going to have a what type of answer? negative. If you have a even number, it's going to be positive. Let's not spend a lot of time in our calculator. You may not know what negative 2 to the 4th power is, but you should know at least that it's positive, right? You should know. Why are we going to spend all this time hitting a parentheses, a negative, a 2, another? So I already know the sign. I can just real quickly do 2 to the 4th power, okay, and get 16. Because there's a problem in here where it happens all the time. Then where you have to do a negative number to an even power. If you don't put it in parentheses, you're going to get a negative answer. Your calculator does exactly what you tell it to do. It does 2 to the 4th power, which is 16, and then it multiplies it by the negative in the front. That's what you told your calculator to do. That's my big pet peeve with scientific calculators. A lot of them just assume that there is a negative, that there's parentheses, so it would automatically make that positive. So you get to this level on these calculators, and we get a little confused with them. So just remember, I don't want to make a mistake in my calculator, and I shouldn't have to put that in my calculator. Odd gives me negative, even gives me positive. Are we good with that? So let's go. Anything to the 0 power is 1. So if I wrote this all out, which you don't have to, I'm just going to be more detailed in this first example. This is 1 times x to the 3rd times 1. Anything to the 0 power is 1. Put that all together, x to the 3rd. Done with that one. And I'm just going to go down the line. I'm going to write above it. 3, right, times x squared times negative 2. So we're just focused on what I have in green here. Put that all together. 3 times negative 2 is negative 6, x squared. 3 times x to the 1st, negative 2. 2 squared is 4, so it doesn't matter if there's a negative or a positive, it's going to be positive. And 3 times 4 is 12. X to the 0 is 1. 3 2's is 8. It's negative, so and that would be your final answer. Look at the patterns. Before you walk away from the problem, double check something. Look, I have 3, 2, 1, 0 x's. It's never going to go like 3, 2, 5, 7 or something weird. There will always be a pattern. It might be counting down, it might be counting up. There's all different things that can happen, but you should see a distinct, recognizable pattern. Also, anytime there's a negative in the middle, like this one, your signs are always going to go positive, negative, always. You'll never have like positive, positive, negative, negative, or any other combination. So that's a great way of catching a mistake you might have made in your signs above, okay? Positive, negative, 3, 2, 1, 0 looks pretty good, right? Let's do another one, okay? The way we start is we go, did someone have a question on that one before I go on? Yep, Remy? Green? Yep, you're multiplying all the stuff in green together to make one term, okay? So on this next one, we have a 4. So I'm going to look at my triangle, find the row that has a 4 in it, and I want to make sure I have those to look at. Okay, so if you want to write it like I do, you want to just look at your triangle, that's fine. Again, I'm showing a lot more work in the beginning. You figure out what makes sense for you. And it is helpful to see, okay, my first term is 2x, right? That's the first term. And what's my second term? What is the second thing? 3? Negative 3. That's what I was getting at. Make sure you understand. It's the negative 3. Those are all the pieces that we need to do this expansion, okay? So starting with 1. 1 is the first one. I'm going to put a 1. And then 2x, always in parentheses. And how do I know what power? Whatever we were given, that's how we start. You'll never go above that number. And then don't forget about your negative 3. and that is always starting at 0. So those two numbers should always add up to the power we're trying to expand to. Okay, so 4 plus 0 is 4. Okay, keep on going. Plus sign. Next coefficient is 4. 2x to the, how do I know which way to go? Oh yeah, she said I'll never go above 4, so I must go down to 3. 4, 3. And even if I didn't go back and look and see that 0, I know this has to add up to 4. So 3 plus 1 would give me 4. 6. 2x to the 4, 3, 2. I'm constantly doing that. I'm constantly like, because I'll stop to talk, or your neighbor might ask you a question, or I might talk to you in the middle of a problem. It's easy to get back in by just saying, okay, a 4, 3, okay, this is a 2, and then the negative 3, 0, 1, okay, that's got to be a 2. Those add up to 4. I'm on track. Next one is a 4. 2x to the 4, 3, 2, 1. Negative 3 to the 0, 1, 2, 3 adds up to 4. I'm looking good. Last one, 1. Okay, are we good there? Everyone with me? Then just be careful with your arithmetic. It's one by one. And remember to check your final answer. So if you messed up on a sign up here, you'll be able to catch it. You'll be able to catch it. But let's make sure we do right signs, because there's other problems where we have to know how to do the signs right. Anything to the 0 power is 1. Ignore that. 1. Ignore that. Simplify this one. 2 to the 4th power is 16. X to the 4th power is x to the 4th power. Okay, so my first term would be 16x to the 4th. Right, times 1 still gives you 16. That's why I said ignore those. Okay, be careful. 4, right, times 2 to the 3rd power is 8. X to the 3rd power is x to the 3rd power. And negative 3 to the 1st power is negative 3. You go to your calculator, you do 4 times 8 times negative 3. You seeing it, Remy? And I get negative 96 x to the 3rd. Looking good. Positive, negative, 4, 3. Keep going. 6 times 2 squared is 4. X squared is x squared. And negative 3 squared, positive 9. I put in my calculator 6 times 4 times 9, and it gave me 216 x to the 2nd. 4 times 2x times, I'm going to get a negative here, right, because it's odd. And if you need to put it in your calculator, go ahead, but it's 27, not 9. Negative 3 times negative 3 times negative 3 is negative 27. Again, I am looking at my key, but previously I put this in my calculator. 4 times 2 times negative 27 happens to be negative 216x. Positive, negative. My pattern's looking good. 4, 3, 2, 1. I'm constantly just kind of looking at that. It's quick math. It's not like I'm getting out a calculator to do that, but it's just keeping me on track. It makes it easier than having to go back and search for your mistake if there is one, okay? This is 1. This is 1. And negative 3 to the 4th power, I put it in my calculator, was positive 81. So there's my final answer. And before I walk away, I'm just double checking those patterns. Positive, negative, 4, 3, 2, 1, none. Everything looks good. Yes. Yes. You say just FOIL it, but you realize if you had to do that 4 times. Yeah. But that's exactly right. I'm glad you asked that, Austin. If I wrote that out 4 times, I would do foiling on 2 of them, foiling on 2 of them, simplify them. Then I'd have to foil those 2. A lot of work, lots of places you could make mistakes. This is the shortcut, okay? I mean, this should not be difficult. There's a lot of places you could make mistakes with signs, but that's what we need to be careful about anyway, so that's what I like about this. Even though you can really check your answer in the end, you're going to catch it. If this was a positive 96 and this is a positive 216, you know something's wrong. You shouldn't have a positive, 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 that negative. There's all patterns. That's what's fun about these. Fun. Okay, the last type of problem we're going to do is example 13. Okay, so listen, I'm almost done. What if I said to you, let's just use this example, this problem we just did. What if I said to you, I don't want the whole answer. I just want, like, this number right here. I would word it like this. I want the coefficient, so coefficient means the number in front of the letters. I want the coefficient of the term that contains x to the second of this binomial. Okay? So I just want the 216. I don't want the whole thing. Do we have to do the whole thing just to get that one number? The answer is no. So look at the next problem. What's the coefficient, meaning the number, of the term that contains x to the 5th of this guy? This is to the 7th power. That's pretty gnarly. That's a lot of expanding. Why would I do that whole thing just to get one single number? There's a shortcut, and it's very, very easy, okay? So here's what you do. You still start out by finding row 7, just like we had to find the row 4, row 3. So look at your row 7, okay? So here's row 7. I'm not going to write the whole thing, but I need to be able to look at row 7. And I'm going to count to the 5th term. I want that one. So remember how we count, and this is what people forget. We start with what? 0. We always start counting with 0, and that's unnatural for us. Remember, row 0 down, term 0. So this is 0, 1, 2, 3, 4. This is my x to the 5th, okay? That's the number we're going to use, 21. Done with Pascal's triangle. We only needed that one number, okay? Then remember what we do. We take the first term and we do something with the last term, right? We have to do something with the x. We have to do something with the 3. What are those somethings? Well, they already spotted us the x. It already told us that. We want the term that's x to the 5th, right? Thank you. We only have to figure out what to do with the 3. What are we going to do with the 3? What power? 2. How'd you know that? It has to add up to 7, right? That's it. And then put that together. So that's 21 times x to the 5th times 9. Put it on my calculator is 189 x to the 5th. So what's the coefficient? 189. Okay? So find the coefficient of the term containing x to the 7th or x to the 6th. You still go to that row, go to that number, and then just expand it from there. Okay? If you guys need me to do another one with you in the homework, I will. But let's go to the homework, and I'm going to do the first one with you. Page 121. Oops, sorry. Let's do that. Let's recreate. You're not doing number 27. 27, I didn't make you do it, but I'm only making you do 2 of these problems, and I'm doing 1 of them with you. There's no reason to do a million of these. Remember, I am not about busy work, but if you felt like you wanted more of the practice, you can check Canvas because I put the whole key there. But only 28 and 29 are these types of problems, and I'm going to do 28 with you. So since 27 is blank, let's recreate the triangle there again, all right, so you have it there to look at and to practice. So recreate your triangle by doing your 1s, okay? You always have, getting started with any of these problems is the hardest. You have to remember, I do the 1s, and then you start your adding, okay? So 1 plus 1 is 2, 1's on the outside. Just keep adding left to right. 1 plus 2, and I put my answer in the middle of the 2 numbers I just added. 2 plus 1 is 3. So if you're wanting to write this in your homework page, number 27 is blank, so hopefully that's where you're writing it, or wherever you want. I just want to make sure you guys understand how to recreate this. We're going to go out to, we're going to go to the 6th row. Okay. Now, just so you know, number 34, it's asking for something in the 8th row. Instead of expanding this to the 8th row, I'm just going to give you the number you need for number 34. It's a 56. That's the coefficient you'll need in number 34, okay? If you just write it off to the side right now, you'll understand when you get there. It is, because it's in the 8th row. It's something to the 8th power. So the numbers get bigger as you go further down. Right. Number 34 is asking for something in the 8th row. So I'm just saying instead of expanding to the 8th row, I'm giving you the number you need out in front. All right. So let's do number 28 together. Everybody there? So number 28 is x minus 2 to the 5th power. Okay. So I need the numbers in the 5th row. And I'm just organizing, I'm going to have x in every single term, and I'm going to have negative 2 in every single term. Those are the two numbers, letters, terms we have, okay? And then we start. Start with the 1, x to the 5th, negative 2 to the 0. Adds up to 5. Plus. Are we all here? I don't want to go too fast if we're not here. Everybody good? Anybody need me to stop for a second? Yep. You okay, Lily? You look sad. Does this math make you sad? No? Okay, good. Okay. All right, next, that's okay. Next one is 5. Then we would count down. How do I know to count down? Because you're never going to go higher than 5. There's only one way to go. 5, 4. Okay? And remember, these have to add up to 5, so if I already used 4, I got 1 left. 4 plus 1 is 5. Five, 4, 3, 0, 1, 2. Adds up to 5. And again. 5, 4, 3, 2, 0, 1, 2, 3, adds up to 5. Five, 4, 3, 2, 1. It's all about patterns. That's why I think it's fun. It's easy. You can almost do it without thinking. 0, 1, 2, 3, 4 adds up to 5. What number did I use? What color didn't I use? Okay, I guess I used them. All right. And then 1, x to the 0, negative 2 to the 5th. If you are comfortable, you can start leaving off the 0 terms here and here because they only equal 1. And so it kind of jumbles up the problem, but it does help you keep track of where you are, like in the beginning and the end. But just know, I normally don't even put these in there because they're just going to equal 1. They don't do anything to the problem, right? So if that makes sense to you and you want to do that, by all means, go ahead. If you don't know what I'm talking about, ignore me. Okay, so here we have 1 times x to the 5th times 1, right? Which is just x to the 5th. Here I have 5 times x to the 4th times negative 2 to the 1st power is negative 2. Put it all together, negative 10x to the 4th. Next one, 10 times x to the third. Negative 2 squared is positive 4. We get 40x to the third. We doing okay? Good. 10x second. Negative 2 to the third power is negative 8. Put it all together. Negative 80x squared. 5 times x times negative 2 to the fourth power. I did it in my calculator and got 16. And then I did 5 times 16 in my calculator and got 80. And then don't forget the x. At any time, stop and take a second and just double check. 5, 4, 3, 2, 1. Looking good. Positive, negative, positive, negative, positive. Things are, my pattern is good. And then that's 1 times negative 32. Again, I'm doing a lot of this in my calculator, so don't think you have to do it all in your head. Okay? Did I lose you, Evan, somewhere in there? Negative 2 to the fifth power. In parentheses, if you need to do it like that. Okay. Good? So 29 is the only other one of those you have to do, and then some of those just finding the coefficient. I'm also going to be checking this assignment. And look, we can do page numbers now. Just that one assignment. Don't wait for me. Just know where it is, so when I come to you, you can just flip to it or whatever. But don't wait. Keep working. Just know where it is.